Welcome to another installment of Chapter 11, More Electron Configurations. Before we do that, I want to talk again and more clearly about the difference between valence electrons and core electrons. And to do that, let's start off with writing the electron configuration for lithium. Well, you should be able to by now to write 1s2 and 2s1. These two electrons are on the first energy level, so we're going to put two electrons in, one there and one there. Now notice you can have a maximum of 2 electrons in the first energy level. No more electrons can go there. I know I'm using the dreaded Bohr model to describe how this works. However, as I said before, there are some uses to the Bohr model, even though we know electrons do not orbit. Now let's take a look at this last electron for lithium. That one is going to be put in the second energy level, where you can actually have 2 electrons. Well, I said that wrong. You can have 8 electrons in the second energy level. What is important about the difference between a valence and a core electron? Well, see these first 2 electrons? They have the exact same electron configuration as helium, and we call these core electrons. I like to think of them as they're the ones on the inside, like an apple core, it's on the inside. These guys do not, this is very important, they do not play chemistry games. And that's why instead of actually writing those core electrons, I can instead write the configuration by starting off with helium, because helium has an electron configuration of 1s2. Let's try another one. Write the electron configuration for sodium. Now let's take a look at what these numbers and stuff mean for core and valence electrons. The first energy level can hold 2 electrons. No more. The second energy level, we've got 2 in the S and 6 in the P. And that's a total of 8 electrons we are allowed to have. Now, because those energy levels are filled, these are what we call core electrons. Can you think of an element that has, let's see, we have 6, 2, and 2, that's 10. An element that has 10 electrons? Neon. Neon has 10 electrons. It's a noble gas. Its electron energy levels are filled. It's just as happy as can be. These electrons do not play chemistry games. I can write the shorthand for sodium like this. This one electron on the outside is sodium's valence electron, and it sits all by itself in that third energy level. Interestingly enough, everything in the very first column has one valence electron, and it's going to lose that valence electron to become like a noble gas. Remember, I've lost an electron. Are you positive? Yeah, in order to become a cation, you have to lose an electron, and everything in the first column loses one electron, and it has one valence electron. Now let's try the electron configuration for beryllium. Should have gotten 1s2, 2s2. Well, for this one, these 2 electrons we're going to put in the first energy level, because we know that the first energy level can hold 2 electrons. These 2 electrons we're going to put in the second energy level, and the second energy level we know can hold a total of 8 electrons. So what do you want to call these first 2 electrons? Well, if you said core electrons, you are correct. And we can replace the 1s2 with helium. It's kind of a shorthand way to do this. The 2 electrons in the second energy level are now called your valence electrons. Beryllium has 2 valence electrons. Let's try another one. Write the electron configuration for magnesium. Well, let's take a look at these electrons. We've got 2 in the first energy level. We have 8 in the second energy level. And what do we call those inner electrons? Well, if you said core electrons, you are correct. Who has 10 total electrons? Yeah, neon. So we can, instead of writing the 1s2 and the 2s2, instead of writing all that, we can just write neon. Now let's look at these s2 electrons. What do we call those? Valence electrons. These are the ones that are going to play the chemistry games. But a second has, you get it, 2 valence electrons as well as helium. But remember when we were doing the S blocks, we actually moved helium to the second column. So that kind of makes sense. Let's look at just one more. What is the electron configuration for chlorine? That's what I got. How many electrons can we fit in the first energy level? That is correct, 2. How many in the second energy level? Yep, 8. There they are. What are we going to call those 10 electrons? They are core electrons. And who else has 10 electrons? That's right, neon. Now that we have the shorthand configuration for chlorine, let's take a look at these last 7 electrons. Where are we going to put them? That's right, in the third energy level. And what do we call those? Valence electrons. You should note the third energy level does hold a maximum of 18 electrons. These are the valence electrons we would deal with in each of the groups. Column 1 has 1, column 2 has 2, column 13. Well, when I was in school, we called this column 13A. No, I lied. It's now 13. We then called it 3A, but it's now called column 13. And that one has all of those, metals and nonmetals alike. They all have, 3 valence electrons. This column, column 14, these guys have 4 valence electrons. Column 15 has 5. 16 has 6. See, there's a pattern, except for helium, because if you remember, helium kind of sits here when it comes to electrons. What is, or I should say, write the full electron configuration for sulfur? I like to start off with the periodic table. Makes my life easier. Show you why. So we're going to start off with sulfur. We always start in the same place. We go across that first row, and that gives us 1s2. Then we come down to the second row, and we end up with 2s2. Following the second energy level over, we now have 2p6. Reading it like a book, left to right, 3s2. Now over to sulfur, 3p4. Now, to write the shorthand electron configuration for sulfur, we want to start with the noble gas who is smaller than the element we're after. If you'll notice, sulfur has 16 electrons. There it says 16. Yes, that's supposed to be the number of protons, but since they're equal for a neutral atom, I'm saying it has 16. What noble gas has less electrons than sulfur? That would be the neon that I circled. So we're going to start by writing neon. We've taken care of all of the core electrons. After neon, then, we have 3s2, and then 3p4, and we're done. Let's write the shorthand electron configuration for gallium. Start with your periodic table. Now, I've put the numbers on here for the energy levels just to remind you. The first energy level for hydrogen, the second energy level for the p block starts with boron, the third energy level for the d block starts right after calcium. Now, if we count straight down from hydrogen, 2 would be lithium, 3 sodium, and 4 would be potassium. Now we're going to start by identifying where gallium is. Gallium has 31 electrons. What is the noble gas that has fewer electrons than gallium? That's right, it's argon. So we can start our configuration with argon. Argon contains all of gallium's core electrons. After that, we're going to read left to right. After argon comes the fourth energy level for the s block. So we're going to write 4s2. Keep reading left to right because now we go into the third energy level. So we're going to write 3d10. Gallium sits just inside the fourth energy level for the p block. If you take a look and you count down from the 2 rather, 2, aluminum starts with 3, and gallium is in the fourth energy level for the p block. If you remember to read your periodic table left to right, it shouldn't be any problem. We're going to do probably one of the most difficult ones to do at this point. I mean, really, they don't get much harder than this one. So let's start with our periodic table and locate hafnium. Oh, it's a good idea to put the energy levels on there. We know that the s block starts with the first energy level, the p block starts with the second, the d block starts with the third, and the f block starts with the fourth. Okay, now locating hafnium is important. So let's do this for a little bit, and then we're going to talk about where things get strange. All right, first off, starting with 1s2, then 2s2, and 2p6, and 3s2, and 3p6, 4s2, 3d10, 4p6, 5s2, 4d10, 5p6, and 6s2. This is where things get a little strange. This is where things get stranger still. If you recall, the S block starts with the first energy level, and sometimes it's a good idea when doing these is just to go ahead and jot down 2 and 3, 4, 5, 6, and 7. And our p block starts with the that's funny, the second energy level. And so 2, 3, this one's 4, 5, 6, and 7. The D block starts with the third, which makes this one 4, 5. Oh, wait, there's where things get funny. And let me show you why. Notice down here at 4, this group is called the lanthanide series, but lanthanide is found right here. So to be honest, for the way this periodic table is written, lanthanide is part of the F block. And since you can only have 14 elements in the F block, that only takes us to there. So Lu is part of the D. So this is 4. This is where 5 would start. And then 6. Another way is I could think of it as 5 and 6 for the D block. Let's see how we would finish finding hafnium's electron configuration. We got to 6s2, which brought us this far. So after 6s2, we're in the lanthanide block, and it starts at the 4th energy level. Well, the lanthanide series, the 4th energy level of the F block. So that takes us over to 4f14. And now hafnium is right there, which makes 5d2. And I don't know why I wrote a 1. Silly me. It should be 5d2. Clear as mud, right? Now let's do the shorthand electron configuration for hafnium. Well, that means we get to start with xenon. That said, so we can write xenon. It is a good idea to go through and write down your energy levels. So here's 1, 2, 3, 4, 5, 6, and 7. And we know that the P block starts with the second energy level, so let's go do those. 2, 3, 4, 5, 6, and 7. The D block starts with the third. 3, 4, 5, 6, and the F block starts with 4, 4, and 5. Okay, now that we have that done, so we need the shorthand. We've got xenon. After xenon, reading left to right, we have 6s2. Then, because this one's really part of the F block, we have 4f14. And Lu is part of the D block, so we have 5d2. And we're done. Try giving number 8 a try by yourself. All right, let's look at the periodic table. There's radium. And so the noble gas that has less electrons than radium is radon. So we will start off with Rn. After Rn comes, 7s2, and we're done. Okay, I know your paper says silicon, but I'd like you to change it to say tin. What is the electron configuration for tin? Pause the video. Try this one on your own. All right, what I like to do, and I'll say it again, I like to put my numbers in. 1, 2, 3, 4, 5, 6, and 7, 2, 3, 4, 5. Since 10's in that line, I'm not going to bother. 3 and 4. Did you get that? Well, hope you did. Well, let's see. We start with krypton, and reading left to right after krypton, we have 5s2, then 4d10, and then 5, oops, right there, p2. For these next two slides, you know what you need to do. And when you're done with those, have a great night.